Welcome back. Today I'm going to be talking about prime factorization and factor trees. So basically, all numbers can be broken down into some number of prime factors. Prime factors cannot be broken down even further into more other factors because the definition of a prime number is a number that only has two factors, one and itself. And a factor tree is one way of determining the set of prime numbers, and it's the main way that we'll be talking about in middle school math. So here's an example of drawing a factor tree for 100. I'm going to show you how to draw a factor tree. So the first step to drawing the factor tree is to write the number 100. Then I'm going to think of two numbers, any two numbers that would multiply to make 100. Doesn't matter which ones. The first ones that come to my mind personally are 2 and 50. So I'm going to write 2 and 50 beneath 100. Then I'm going to check if either of these are prime numbers. Well, yes, 2 is a prime number. 2 does not have any factors other than 1 and itself, so I'm going to circle it to show that this is a prime factor. Then I'm going to turn my attention to 50. 50 is not a prime number, and so I need to continue. What are two numbers that multiply to 50? Well, 10 and 5 do, so I'm going to use 10 and 5. And 5 is prime, but 10 is not, so I'll be circling 5. Then I have a 10 left. What two numbers multiply to make 10? Well, 5 and 2 make 10. So I'll be putting in 5 and 2 and circling those. And there we go. So therefore, what does this tell us? What's the purpose of this? Well, this tells us that 100 can be rewritten as 2 squared times 5 squared because there's two 2's, 1, 2, and there's two 5's, 1, 2. So 2 times 2 times 5 is 100. And this can be useful for things like least common multiple, greatest common factor, that sort of thing, which I won't get into much today, but I do have other videos on those topics in the middle school math series if you're interested in those. Now, a common question I get asked is, okay, but what if we hadn't chosen 2 and 50 in the beginning? What if we'd chosen some other two numbers to multiply? How do we know the right ones to multiply? And that's a great question because you're right, absolutely. 2 and 50 isn't the only way to make 100. However, what I will say is that any one that you choose first doesn't really make a difference because either way, you're going to get the same thing in the end. Even if your factor tree looks different from someone else's, as long as your prime factors are the same, you're good to go. So let's say instead of doing 2 and 50, I'd done 10 and 10, for example, and then each of those 10s had broken down into 5 and 2, well, I would still end up with, although it's a different looking factor tree, I still end up with two 2's and two 5's. Or what if I'd done 4 and 25, for example? Well, then the 4 would be 2 times 2, the 5 or the 25 would be 5 times 5, and once again, even though my factor tree looks a little bit different, I still have two 2's and two 5's. And so, regardless of which numbers, of which multiples we choose, or sorry, not multiples, regardless of which factors we choose, we're going to end up with the same prime factors if we do it correctly. And so that's the good news is we don't have to, worry about which ones we're choosing or not choosing because either way we'll get the same results in the end. The point isn't to have a factor tree that looks a certain way. The point is to find the prime factors. Let's do one more example. Draw a factor tree for 990. Okay, so let's do that. Well, 990 is equal to definitely 10 times something, 10 times 99. So we'll do that one first. Then 10 is 5 and 2, which those are both prime, so that ends that branch. Then we have 99. 11 times 9 is 99, so I'll be going with that. And 11, although it's bigger than 9, is prime. There are no numbers other than 1 and 11 that are factors of 11, so I'm going to circle it. 9 is 3 and 3, which are both prime. So therefore, 990 is equal to 2 times 3 squared times 5 times 11. And there we go. As always, if you do have any questions, feel free to put those down in the comment section, and we'll see you for the next one.